Hey YouTube, what's going on? I'm Greg. Welcome back to my machine shop. Today we're going to tackle one of the more challenging components for our Wallaby 30cc engine build, the cylinder head. We're going to be machining it from a block of aluminum, rectangular block like this. What makes this component a little challenging is that we have to machine all 6 sides of the cylinder head, and we want the features to be in alignment with each other. This is a 3D printed model of the cylinder head. And we can see that on the bottom, we have our combustion chambers. On the top, we have some coolant passages. The spark plugs mount on this side, the carburetor on this side, and the exhaust pipes mount here and here on these sides. We've developed all of the skills we need to machine the cylinder head. It's not particularly difficult, but it does take patience because of the many setups that are required and the importance of aligning the features we make on each of the sides. In addition, a few of the features that we machine require the head to be clamped at an angle. So that's one more thing a little bit out of the ordinary. And finally, we will be needing to use a boring bar on a couple of the operations, such as the combustion chamber and the flat for the spark plug. If you're interested in reviewing the use of the boring bar, you can go back and review the cylinder block video where we discuss the boring bar in a fair amount of detail. Now, as usual throughout this build, I've produced 2 sets of plans for the cylinder head. One is intended for manual machining and one is intended for CNC machining. The plan set for manual machining is broken down side by side by side, detailing each of the features we machine on each side. In this video series, I'm going to be machining my cylinder head on the CNC machine and then taking it over to the manual mill and setting it up and explaining how we would do the same features on the manual mill. And again, remember, the plans are available free of charge on my website, gregsmachineshop.com. On my Patreon page, I've supplied some additional files, particularly for CNC machining, the models, the tool paths, etc. All right, enough talking. Let's jump into it. Let's take a look at our print for the cylinder head. Let's begin by machining the bottom, the combustion chamber. Take our aluminum, we're going to drill the 10 holes for the head studs that mount us to the... Then we're going to drill the 5 coolant holes. These are 0.188. And finally, we're going to do the machining for the combustion chamber itself, which consists of 2 pockets, which we'll do with the boring bar, and then 4 features here that will hold the valve cage that will slide into here, okay? So let's set this up in the mill and take a look at that. When machining a workpiece from multiple sides, it's important to touch off on the same surfaces in each of the orientations. I want you to notice that on the print, the spark plug side of the head is marked with this A, marking that as a major datum plane that all measurements are taken from, and as the edge we'll use the edge finder to touch off our y-axis. The x-axis is zeroed to the center of the workpiece, so we'll touch off on 2 edges to establish this datum plane. Once we've zeroed our x and y axes, the drilling of the head bolt holes and the coolant holes is pretty straightforward. We double check our DRO twice, center drill, and then drill each hole. Next up, we've got the machining of the combustion chambers and the holes for the valve cages. I make the initial entry point with a 1/2 inch end mill. This gives me a nice pocket with a flat bottom that I can then use the boring head to widen the hole. And yes, the boring head. I don't know why this whole video I've been calling it a boring bar. That's something we use on a lathe. Here we use the boring head. If you've not used a boring head before, refer back to my machining of the cylinder block as I go into greater detail on how to set up and use the boring head. So once we've drilled out the holes for the valve cages, we can drill the holes for the intake passages and the exhaust passages. The way we do this is we first drill the entry hole straight into the part. And then we mount the part at an angle, use a 1/4 inch end mill to drill at an angle down until we break through into the valve cage hole. Then we widen it with a 5/16 drill to the desired width. So for the intake manifold, the entry hole is drilled 328.35 inches deep, and it'll eventually be tapped. But we drill this hole first, straight down. Then we mount it at an angle, 22.5 degree angle, and drill first with the 1/4 inch end mill, and then widen it out to 0.3125. The exhaust passages are machined in the exact same way. First, a straight entry hole is drilled, and then an angle hole is drilled. We use a 1/4 inch end mill to start this hole because it goes at an angle and we don't want the drill to wander. These are a couple of interesting views with the bore for the valve cage illuminated through the intake and exhaust ports. It's now time to flip the cylinder head over and machine the coolant passages in the top. To manually machine the coolant passages on the top of the head, you can refer to sheet 5 of the plans. You can see we've machined a trough through here with a 1/4 inch ball-end mill, essentially connecting all of the coolant holes. Okay, and then this big area here between the spark plugs, we use a 1/2 inch drill to drill this out. So to manually machine it, I would use this drawing here and these dimensions to scribe where these troughs are machined into the top of the head, and then machine those with the 1/4 inch ball-end mill. Drill this hole 3/4 of an inch deep, and that will provide the coolant passages in the cylinder head. All right, well, let's stop there. We finished machining the bottom of our cylinder head, the top of the cylinder head with its coolant passages, and also the intake and exhaust ports. Next time, we'll finish up all of the sides of the cylinder head, including the spark plug entry holes and the mounting points for the carburetor and the exhaust pipes. I tried something a little bit different in this video. Tried to cover both the manual machining and CNC machining in one video. CNC machining my part, and then discussing the manual machining operations on it. I don't think that was quite as clear as I was hoping it would be. Let me know what you think. So, until next time, I'm Greg. Thanks for visiting me in my machine shop. Take care.